Car accidents happen frequently nowadays, with the increase in the number of cars which leads to a higher percentage of occurrence of an accident. But how the manufacturers approach this issue may decrease the percentage. Our system will introduce a mini seatbelt pressure system like that in cars now. The system will have three inputs: a proximity sensor that sends a signal when there is a pressure applied to it, a keyboard which uses the O button as a button to turn the engine of the car on, and the switch that acts like a seat belt. It will have three outputs: a red LED, a one green LED, and an alarm that go on and off depending on the inputs.
Our design consists of an Altera, proximity sensor, breadboard, alarm, and the PS2 keyboard, which are all functioning using a Verilog code from the Quartus software. And now we'll talk about the connections. The proximity sensor is connected to the Altera through a wire which is connected to the 5-volt pin, so this sensor can work. Another connection from the sensor to the Altera is the wire which is connected to the input pin, so we can input anything from this sensor. And now we will talk about the breadboard. The breadboard has three wires which are connected in parallel, and these wires represents the ground. One of the wires are connected to the ground of the Altera, so we can make a ground. The keyboard is connected to the Altera through a board. And finally, the alarm. The alarm is connected to the breadboard, so the negative can have the ground and the positive can have an output pin, so when this output pin gives it 1, the alarm goes off.
Our code consists of three modules. First, there's the keyboard module, which takes the input from the PS2 port in the Altera and outputs 8 bits. If the pressed button is O, for example, then the transmitted bits are represented in 44 in hexadecimal. The output of this module is transmitted into the second module that checks the output. If the pressed button is equal O, then the output is 1. Otherwise, the output is 0. The output of this module is transmitted into the main module, which takes also two other inputs, which is the proximity sensor, which represents whether a person is sitting inside the car or not, and the switch, which represents that the seat belt is fastened.
Our project contains 4 states. The first state is when the car is turned off. The Altera declares a statement off, which means that the car can't move because it's off. The second state is when the car is turned on, but there is nobody inside. The Altera declares a statement none, which means that there is nobody inside the car, so it can't move. The third state is when the car is on and there is somebody inside and his seatbelt is fastened. The Altera represents this state by giving a go statement and a green LED light, which means that it's all clear to move the car. The fourth state is when the car is on and there's somebody inside but his seatbelt is not fastened. The Altera declares a statement, stop, a red LED light, and an alert sound. This means that you can't move the car, and until the seatbelt is fastened, the alert will keep on buzzing, and when the seatbelt is fastened, we will be redirected to the third state.
Now we will test our project. Run the code. Firstly, the car is off, and as you can see, the Altera gives the off statement. We will turn on the car by pressing the button on the keyboard. Now the Altera gives the run statement, since the car is on, but there is nobody inside. Now we will use the proximity sensor to detect presence in the car. Now the Altera is giving the statement stop, a red LED is on, and the alarm is beeping, since somebody is in the car but his seat belt is not fastened. By turning on the switch, which represents the seat belt, the Altera now shows a statement go and the green LED light, which gives the all clear to move the car since the car is on and the seat belt is fastened.